So this is going to extend to right and left-hand limits as well. Okay, so if I want to approach just from the right, I'd put a plus sign there. If I want to approach from the left, I'd put a minus sign there, just like we did in previous questions. Okay? So one thing I just want to make sure you're taking away from this, we're still claiming that the limit doesn't exist, but we're doing a better job of describing how the function's behaving at that point, at that x coordinate. Okay. All right. If the left, right, or limit proper comes out to be plus or minus infinity, then we will say the graph of f has a vertical asymptote at x equals a. So we sort of, I mean, you encounter asymptotes early on in like an Algebra 2 course. You see asymptotes, but you don't usually get limits until later on. Okay? But really, an asymptote is, a vertical asymptote is defined to be a situation where as we approach a particular domain or a particular x value, the limit came out to be either plus or minus infinity. When that happens, we say that there's a vertical asymptote there. But graphically, we've already learned what vertical asymptotes look like. Okay? Graphically, you've encountered enough of these to say, oh yeah, I see there's a vertical asymptote here at x equals 0. But what justifies that? The fact that either the left, right, or limit proper came out to be, is written as infinity, arbitrarily large. All right, working with limits where the output becomes arbitrarily large positive or arbitrarily large negative is difficult to do. We will prove one of them in section 2.7 with what's called the epsilon, with the epsilon definition of the limit. Okay? But it's an extremely complicated, well, I shouldn't say extremely, it's a chore. Okay? So I'm going to give you some facts that you can take from here on out. Now, these facts are true as I give them to you, but what happens is people start applying them in contexts where they don't apply. Okay? So all of the ideas that I'm going to give here in 7, which will be your takeaway point for this section, come from these unproven facts that I'm going to show you here. If you ever have any confusion about what's going on with 7, return to these unproven facts. Okay? Because you can't go wrong looking at this, where sometimes I've seen students kind of back themselves into a corner misusing these statements here. Okay? So, an unproven fact. If we look at the limit as x approaches 0 from the right of the function 1 over x, this limit comes out to be positive infinity. Now, I'm saying the limit comes out to be positive infinity. That's sort of poor vocabulary. What I'm saying is, as the domain values get close to 0 from the right, what do the range values do? They get arbitrarily large. Okay? So we get sloppy as we talk about it. We say the limit is infinity, but what we really mean is the range values are doing what? Getting large. Okay? So the domain value that we're approaching is 0. The range values are getting arbitrarily large. Similarly, if we look at the limit as x approaches 0 from the left of 1 over x, this equals minus infinity. Okay. For these section 2.4 questions, you usually don't need to show me any work because you just fall back on this unproven fact. So there's no real work to show for them. Okay? So what are these two ideas? A positive quantity that does not approach 0 divided by a arbitrarily small positive number approaches infinity. Okay, think about that for a second. If I take the number, I don't know, if I take the number 23, if I take the number 23 and divide it by 0.1, what do I get? 230. If I take the number 23 and divide it by 0.01, what do I get? 2,300. If I take the number 23 and divide it by 0.00001, I get a very large positive number. The closer this expression gets to 0, the more large the quotient becomes, so we're approaching infinity. Now, the thing that is critical here is this might be 23.1, and this might be 23.01, and this might be 23.001 as you're evaluating limits, looking at the overall structure of it, but it's approaching a positive number. Specifically, it's not approaching 0. Okay? If both of these are approaching 0, these statements in 7 don't apply. Okay? That's really, really important. All right. Same thing. If a positive quantity that does not approach 0 is divided by an arbitrarily small negative number, then the whole quantity, the quotient approaches negative infinity.